Hi dear. So last class we have seen the defects of vision, right, and its correctness. Okay, so you know that myopia can be corrected by having a concave lens, and hypermetropia can be corrected by using a convex lens, and presbyopia can be corrected by having a bifocal length, right, bifocal length, and we'll be having a concave lens at the upper part of the spectacles, and bottom will have a convex lens for nearer vision, and for this upper part helps in the distance vision. Okay, so we'll see some of the numericals from this part. Okay, a person suffering from eye defect myopia, okay, that means short sightedness, they are able to see the nearby things clearly. Okay, can see clearly only up to a distance of 2 meter. Okay, the person can see us, since he is a short sightedness, he is able to see things clearly up to 2 meters only. Okay, that means what, this is his far point of the eye, right, this is the far point of the eye, he is able to see things within 2 meters, right. What is the nature and power of the lens required to rectify his defect? Okay, since it is myopia, you know that you have to use the concave lens. Okay, but we are asked to find the power of the lens also, right. So this myopia can be corrected by wearing spectacles with concave lens. So we need to find the power of the concave lens. Okay, for that, before that, we need to find the focal length. You know that power is related with the focal length, right, power is indirectly proportional to the focal length. So first, using the data, we need to first find the focal length of the lens, then only we can find the power of the lens required. Okay, so what is given from this, we can write this as you know that this is your eye, this is this person eye, this is your lens. So somewhere infinity, he is not able to see the, for example, a tree is here. Okay, a tree is here, take this as tree. Okay, a tree is here, he is not able to see this tree clearly. Okay, but his far point of the eye is present here, 2 meter, at a distance of 2 meter. So if I able to bring the tree image here using the lens, he is able to see the picture clearly. Am I right? So our object distance is at infinity, right? That means to find the focal length of the lens, our object distance is this is your object distance is at infinity. Okay, your image distance should be at 2 meters. Okay, you know the u value, you know the v value. From that we can easily find the, using the lens formula, you can find the focal length of the lens we are going to use. Okay, if I am going to keep a concave lens here, then the object is present here, image has to be formed here, right, at a 2 meter distance. Okay, for that, what will be the focal length of the lens required? Okay, so your u, object distance, is equals to infinity. Okay, then v, image distance, is equals to 2 meters. Since it is left side of this, for concave lens always you will get a virtual and direct image. So it will be in the negative side of the x-axis. So it is minus 2 meter. Always concentrate on the signs. Okay, then you don't know f. So what is the lens formula? 1 by f is equals to 1 by v minus 1 by u. Okay, so substitute the value of 1 by v. 1 by v is minus 2 by 1 by u is 1 by infinity. 1 by infinity, you can take it as 0. So 1 by minus 2, 1 by f is equals to 1 by minus 2. Therefore f equals to, if you cross multiply, f equals to minus 2 meter. So we found the value of the focal length. The lens we are going to use will have a focal length of minus 2 meter. Okay, minus 2 meter. So from this you can easily find the power. What is the power formula? P is equals to 1 by f. Okay, you have to substitute the value of f in meters only. Remember that. Okay. So already we got the value in meters only. So P is equals to 1 by minus 2. That is equals to P equals to 1 by 2 means what? Minus 0.5 D. Okay. D means what? Diopters. So the power is given in negative. That means you are going to use the concave lens of power 0.5 diopters. Concave lens. Clear? We'll see one more question. The near point of a person suffering from hypermetropia is at 50 centimeter from his eyes. Okay. Hypermetropia means he's not able to see the nearby things. Okay. So his nearby things can be seen at a when it is kept at a distance of 50 centimeter. That is, his near point of the eye is 50 centimeter from his eyes. What is the nature and power of the lens needed to correct this defect? Okay, nature, you know, if it is hypermetropia means it can be corrected by using a convex lens, right? Hypermetropia can be corrected by wearing a spectacles with convex lens. Okay. Assume that the near point of the normal eye is 25 centimeter. They are given that, given the hint that we have to assume the normal point of the, you know that, right? Near point of a normal eye is 25 centimeter, right? Far point will be infinity, that we know. Okay. So, what we have to do means here, this is the eye, the convex lens. Okay. So, for example, this is the near point. This is 25 centimeter means he is not able to see the image when it is kept here. Okay. Because his near point is 50 centimeter. Okay. His near point is 50 centimeter here. If you keep the object, if you bring the object image here, he is able to see the image properly. Correct? Right? See. For example, your plant is here. A book at 25 centimeter. A book is here. Okay, you are going to read this book. If the book is kept at 25 centimeter, he is not able to read it. Okay, if you bring the image of this book at a distance of 50 centimeter, he is able to read the book clearly. Okay. So, what is the power required? Power of the lens needed to correct this defect. For this lens, the convex lens to keep what will be the convex lens to be used in the spectacles. Okay, for same way we are going to calculate that. For finding the power, before that we need to find the focal length of the lens, then only we can find the power of the lens. Okay, so focal length, you know, this is your actual object distance. Your object distance should be at 25 centimeter, but he is not able to see that. So we are trying to bring the image at a distance of 50 centimeter. So your image distance will be 50 centimeter. Your object distance will be 25 centimeter. Okay, we are trying to bring the image of the object present at 25 centimeter into 50 centimeter. Okay, so what is given? Object distance is at 25 centimeter. So this is minus 25 centimeter. Okay, V is also V is also minus 50 centimeter. Everything at the negative side of the x-axis. Okay, so we need, from this value, we need to find the value of f. 1 by f equals to 1 by v minus 1 by u, right? That is equals to 1 by minus 50 minus 1 by minus 25, right? So denominator, negative sign should not be there in the denominator, so it becomes minus 1 by 50 minus 1 by 25. Okay, so what is the LCM of 50 and 25? If two numbers are there, if one of the number is a multiple of the other, then the biggest number is your LCM. Okay, so 25 into 2 is 50, so 50 is your LCM. So 50 here, 25 into 2 here also 2, that is equals to minus 1 by 50, minus into minus plus. So okay, first we put minus 2 by 50, common denominator 50 here minus 1 minus into minus plus plus 2, that is equals to plus minus means we have to do the subtraction only. 2 minus 1 is 1, bigger number is plus, bigger number sign is plus, so 1 by 50. Okay, this is 1 by f equals to 1 by 50. Therefore f equals to 50 centimeter. Okay, remember that if it is in centimeter, we need to convert them into meters before substituting in power formula. Okay, so that is equals to 1 centimeter equal to 1 by 100 meters, that is equals to 50 by 100, that is equals to 0.5 meters. So your f is equals to 0.5 meters. So therefore power equals to 1 by f, that is equals to 1 by 0.5. So both the denominator and numerator multiply by 10 becomes 10 by 5, that is equals to 2. So P equals to 2, it is positive 2D. Okay, that means he need a convex lens of power 2 diopters. Okay, this is convex lens. Since the power is given in the positive form, already we found that for hypermetropia we are going to use a convex lens only. So we are getting the answer in positive D itself. Okay, P equals to 2D. So he is required 2 diopters powers of convex lens. Okay, we'll see one more numericals in this defects of vision. Okay, a person needs a lens of power minus 5.5 diopters for correcting his distance vision. For correcting his distance vision, he is going to use minus 5.5 diopters. For correcting his near vision, he needs a lens of power 1.5 diopters. What is the focal length of the lens required for correcting? So in the previous two sum they asked for the power. For that we need the focal length, right? The focal length value can be calculated using the value of image distance and object distance. Okay, here they are directly given the power of the lens has been given. We are supposed to find only the focal length of the lens required. Okay, for the distance vision, also for near vision. So he is going to correct the distance vision, means what type of person he is. He is myopic person, right? Myopia. Okay, a myopia can be corrected by using what lens? Concave lens. Concave lens. Hence they are using the power of minus 5.5 diopters. Okay, minus 5.5 diopters. Okay, for the near vision, that means hypermetropia. Hypermetropia, it can be corrected by using a convex lens, and that's why they are using the power of 1.5 diopters. Okay, plus 1.5 diopters. Okay, so we need to find the focal length of this lens using this power. You know that P is equals to 1 by F. Therefore you can write F is equals to 1 by P. Cross multiply this 1 by P, right? So F is equals to 1 by P, that is equals to 1 by, what is the value? Minus 5.5. Okay, that is equals to, we cannot do the division by this, so need to multiply both the numerator and denominator by the 10. Then it becomes 10 divided by 55. Okay, we need to do the division for this. Okay, we'll do it here. 55. So 0 times 0 becomes 100. 100 means 1 time. 55. 5. 9. It becomes 9. 9. 4. Okay. Then one more time. 0. Almost how many times? In 100 approximately 2 times. So for we are having 450 means we can take 8 times. 8 times pick up. Okay, 8 5s are 40. 0 balance 4 40 44. Okay, 0 1. Okay, again it is repeating. 0 means then it comes out to 1 and again it will repeating. Okay, 1 8 1 8 will repeat like this. Okay, so that is equals to f is equals to 0.1818. This is meter, right? Okay, since they asked for the focal length of the lens, we can give the centimeter. F equals to 18.18 centimeters. This is the focal length of the minus, forget the minus. Okay, minus 18.18 centimeter. Okay, for the near vision we'll calculate now. P is equals to 1 by f. This implies f is equals to 1 by p. F of f equals to 1 by 1.5. 1 by 1.5 into 10. Here also 10, that is equal to 10 by 15. The division here. 0 times 0, 6 times, right? 30, 0, balance 3, 90, 10. Again 0 means 100 means 6 will repeat. Okay, for f equals to 0.666 will repeat. So this is in meters. For f is equals to 66.66 centimeter. This is the focal length of the convex lens for correcting his near vision. Okay.